Okay, so let's interpret some confidence intervals in some common places where we might find them. One would be political polls. This is an article I just pulled up right now. Notice that they sampled about 2,000 voters. Hopefully they got it says national survey. Hopefully they got a representative sample. That's always a question, and that can really impact the results that they got. But what I want to focus on here is this 2-point margin of error. What is that, and how does it relate to a confidence interval? Essentially what they're saying is, yeah, they asked 2,000 people, and of these 2,000 people they surveyed, if there was a Trump-Biden matchup, 34% said that they would vote for Donald Trump. Now what we can also say is that probably if we had an election today between Trump and Biden as the two contenders, we probably would not have exactly 34% of the people voting for Trump, right? It might be lower, might be higher. What we can say pretty confidently is that, yeah, this results from these 2,000 voters can't represent 320 million people exactly. And so we put it on what's called this margin of error, which is really a confidence interval. This is another way of looking at confidence interval. And the way to interpret this margin of error is that if we would take these 2 points and go below the sample results and then 2 points above the sample results. And sometimes you'll see it as plus or minus 2%. In fact, I doubt if you can see that, but under this it says plus or minus 2%. So what they're really saying is, okay, our 2,000 voters said 34% of them said they would vote for Trump in this matchup. But what we're pretty sure is that if we looked between 32% and 36%, so 2 points below and 2 points above this number, we're pretty confident that that range would capture the true percent of people who would vote for Donald Trump today, if an election was given today. So that's a confidence interval. A confidence interval would write it as 32% to 36%, or it could say 34% plus or minus 2%. The basic point being, we're pretty confident, typically 95% confident, that somewhere within that range that we've created would include the true population percent, not just what we found in our sample. What about in a study? This is a study on college students in the Appalachian region and how their diet and mental health might be connected. Let's focus in just on a specific one here in their results. Let's look at anxiety in females, and let's look at the food insecurity. So we're looking at this idea that a college female might not have a dependable source of healthy food. And then are female students, college students in that situation, more likely to exhibit anxiety? And if we look at that, we have this right here. These would be the results for the added sugar difference. This is the one here for the anxiety. And how do we make sense of this? Well, first of all, an odds ratio tells us that in the sample, in the 1,900 and some college students that they looked at here, the females who reported being insecure or having food insecurity, not having a dependable source of food, were 1.65 times as likely to also exhibit anxiety than their college female counterparts who did not report having food insecurity. So they're more likely. It's more likely that the college females who have food insecurity are reporting experiencing anxiety, 1.65 times as likely among these 2,000 students. Now, if we want to generalize to a population, and this might be college females in general, although we have to be a little careful because college females may not be the same in Appalachian colleges or Appalachian regions as they would throughout the United States. So we need to think about what this sample would actually represent. But this confidence interval right here, 95% confidence interval, what does that tell us? Well, again, in our sample of 1,900 students, the college females who had food insecurity were 1.65 times as likely to report anxiety. In our broader population, whatever we decide that's going to be, whatever we decide can be represented by the females in this sample, we are pretty sure that within this range, so between 1.27 times as likely to be anxious and 2.16 times as likely to be anxious, we would have the actual odds or odds ratio of females with food insecurity being anxious. So we're essentially not really sure where it is. Probably somewhere between 1.27 and 2.16, but we're not exactly sure. What is worth noting is that even in this kind of conservative estimate of what's food insecurity is predicting, even on the lower end of our guess, we're saying that the college females who are reporting food insecurity are 1.27 times as anxious, likely to be anxious, whereas perhaps that could be even 2 times as likely to be anxious, or even slightly more than that. So that's the range we're looking at. Now, let me also add, this is a tangent that's not connected to confidence intervals, but is very connected to the main points of this course. Just because these girls who are having food insecurity are more likely to exhibit anxiety does not mean that the food insecurity is causing that anxiety. It's very possible that there are other reasons. For example, poverty. Certainly, the college females experiencing food insecurity are much more likely to be living in poverty, and poverty itself could have a variety, or does have a variety of reasons why it can cause anxiety. So this gives evidence, it gives predictive power. We might be able to conduct a further study to actually look at how much that food insecurity is actually causing anxiety. But for now, what it tells us is that if we are looking at the college females who are food insecure, especially in this Appalachian college that we're looking at here, it is more likely that these girls will be suffering from anxiety. And that in itself is an important finding. A little bit lighter example here, weather forecast. So Norway puts confidence intervals on its predictions. Not only does it tell you the prediction, but it tells you how likely it is that that prediction will come true, which would be a really nice thing to have. And so if we look at, say, Wednesday, May 15th, and this is currently 1 week away from when I'm making this video, we see that the best possible prediction for the high temperature that day is 18 degrees Celsius. However, they also recognize that the weather forecast could be a bit off, and so they put here this probability. This is a confidence interval. In other words, if you would take the range between, looks like 14-ish degrees Celsius and 19 degrees Celsius, we're 50% sure that the high that day on Wednesday, May 15th, will be somewhere in that range. And if we wanted to be a bit more sure that we were trying to figure out what this high was going to be, we could look at the 80% confidence interval, and that would be ranging from 12 to 21 degrees Celsius. Within that range, there's 80%, we're adding up these two probabilities, 80% sure that the average or the high temperature will be somewhere in between those two numbers. So how do we actually calculate a confidence interval? Typically you could just Google it. It kind of depends on what you're actually estimating. And notice that this really only comes into play when you have a sample and you're trying to make a prediction on a population, which is the case for my sleep patterns, right? I have a sample of nights when I've collected data, and what I really want to know is kind of where is my true average at. It looks like I highlighted the wrong column here, so I'm going to go after this total sleep in minutes. So what I've done is between last July and August, I have the total amount of sleep I got on several nights. And the first thing I want to do is create an average for that. So the average would be typing in equals average, and then I could select those data points right there, close off the parentheses, and this would give me my average amount of time actually sleeping for these 24 data points would be 353 minutes, a little less than 6 hours a night. But I also know that I'm gonna give myself a little more room here. I also know that is just based on these 24 data points. So 25 rows minus that row of column headers gives me 24 rows of data here. And here's where I want to create a confidence interval. So let me, I'm going to call it error margin, like in that Political article, because that's really what this formula gives us. Equals, so you type in confidence. Notice it does tell you that this assumes that you're dealing with a normal distribution. And in this case, the sleep time is probably normal. If you were dealing with a different, not normal distribution, that's where a web search could help you get a calculator to calculate the confidence interval. But in this case, we're going to start off, if I click this question mark, it'll tell me what I need to put into this formula. I start off with alpha. This is 1 minus the confidence interval. And so if I'm looking for a 95% confidence interval, I'm taking 100% minus 95%, which gives me 5%. I'm going to type that in as 0.05 in the decimal format. Now I need the standard deviation. Instead of calculating that one by one, I'm just going to grab the standard deviation of these numbers. And then I need a population size. This is a little deceptive. What we're really looking for is how big of a sample size do I have here. And like I said, I have 24 data points. So I'm going to close off that formula. And this will give me an error margin of, in other words, this is that plus or minus of minutes. So if this is my average that I had in my actual sample, and this is going to be kind of my low estimate, this is going to be my high estimate for how much actual sleep I get in general per night. What I'm going to do is I'm going to take my average and subtract that error margin, and then I'm going to come up here and I'm going to take that average and I'm going to add the error margin. This is that plus or minus concept. So my confidence interval here is 338 to 368. If I was convinced that this was a representative sample of all of my nights of sleep in my current age, then I could be 95% confident that this range right here between 338 minutes and 368 minutes, somewhere in that range would be my actual number of minutes I'm getting per sleep. Not just on these 24 nights, but in general and on a much wider range.